I'm Wesseling, neuropathologist. I figured out that I could take a stroll because it's nice weather outside, and then I lost my way. But then I entered here, and one of the colleagues in one of the other rooms said, "Don't worry, it's a workshop, it's very relaxed." So that's what I like. I'm kind of what David Ellison once called terminally differentiated pathologist, because I ended up in neuropathology. And neuropathology still is a kind of broad area with neurodegenerative, muscle, nerve diseases, etc. But I'm only involved in the diagnostic workup and research and teaching of CNS tumors. So this gives me a kind of limited view, but on the other hand, it allows you to dig in deep. I saw this COP-E image, and I was wondering, this is about the kids, right? That walk there. Yeah, because now it should be replaced by, how do you call them, iPads and telephones, right, rather than books. My talk will be about the WHO classification of CNS tumors. Who of you were present at the ISPNO meeting last year? Because there's quite some overlap. Okay, so you can go. There are some new elements, but there's also quite some overlap. Hope you don't mind. What I would like to do is talk a little bit about the genesis, or the history of the WHO classification, what has changed in the 2021 version of the classification, and what are the challenges, or some of the challenges we are facing when building a WHO classification. As far as I'm concerned, it's perfectly fine to have an informal meeting, so feel free to interact with me during the talk, and we'll see where we end. The last couple of slides are not the most important ones, so when I am not able to show those, no problem, but then I'm better able to respond to your needs in a way. Professional needs, I mean. The revised 4th edition of the WHO classification of CNS tumors was the first one that actually had molecular features integrated in the definition of particular tumors. And this was especially true for adult-type diffuse gliomas and for embryonal tumors. And because of the rapid developments in molecular diagnostics and molecular knowledge, it was felt necessary not to wait for the 5th edition to be published, but to have a revised 4th edition in between the 4th and the 5th edition. And here you see in one scheme what changed for the diffuse gliomas. That most of these are adult-type diffuse gliomas, so I'll not go into detail on these. But also for the first time, there was what was called then H3K27M mutant diffuse midline glioma included in the 2016 classification. Are these slides shared with the participants, or how does it work? Because I see some people taking notes, but when you get the slides later on...
If you allow it,
sure. It's good to live in a free world and share freely, I guess.
Science has to be free.
Exactly. And a lot of other stuff as well. But even while some of us, especially the pathologists, thought that there was a lot of progress being made, other colleagues around the world thought we didn't do a good enough job and still considered it as a kind of activity of dinosaurs, still a lot based on morphology, etc. So you can never make each and everyone happy. But one of the problems we are facing is that not everywhere around the world, or even in Europe, all the tools are available to make the most optimal diagnosis when you include a lot of molecular features in the definition. There were two very important developments after the publication of the revised 4th edition. One is this one, a paper published in 2018 in Nature by David Kapper with Stefan Pfister and Andreas von Daimling and a lot of other colleagues from Heidelberg and also from other centers in Europe and in the USA or North America being involved. And methylation profiling, in fact, is looking at the methylation or methylome fingerprint of tumors with a tool that allowed you in the past to look at 450,000 spots along all chromosomes. And the more recent version of the chip allows you to look at over 850,000 spots. And this then provides you with an epigenetic fingerprint of the tumor, and the Heidelberg colleagues build a classifier, and you can match new cases with the information in the database, and then the system spits out, in a way, a suggestion for a diagnosis. This is from the 2018 paper, and a TSNE plot is shown. And you see that, for instance, the posterior fossa tumors, medulloblastomas, different kinds, posterior fossa ependymomas, pilocytic astrocytomas in the posterior fossa, clearly end up in different groups. So a next case can then be matched with what is known in the database. And as I said, before even looking at the slide, you get a suggestion for a diagnosis, which is somewhat frightening for traditional pathologists. But we, of course, need to think about the patient first. So it's not about our jobs, but providing the best diagnosis possible for the patient. It was still kind of reassuring that it was not completely different from what we used to do based on morphology, including immunohistochemistry. But building this classifier and this database, increasingly new types and subtypes were recognized. So this is a very informative tool for recognizing new tumor types or subtypes within particular tumors. And at least a dozen papers are published each year with the suggestion of a new type has been identified. And then the WHO needs to make sure that the type is mature enough to be included in the WHO classification, and that's quite something. Still, this development was presented in one of the pathology or neuropathology journals as HEIRECA, the Heidelberg Revolution of Cancer Classification, and what it means for neuro-oncology and neuropathology. And in fact, it's really a revolutionary tool because it gives a lot of information from a different angle, and you can use it as additional information, and sometimes it overrides what we think as pathologists based on our morphological approach. The second development was the establishment of a consortium, See Impact Now, and the acronym is nice because we would like to see impact now and not tomorrow or next year or so. We would like to see impact now of what we are doing. But it's the acronym of Consortium to Inform Molecular and Practical Approaches to CNS Tumor Taxonomy. Andreas von Dijmling and David Lewis were, in fact, the initiators of this endeavor. And from the start, there was also a clinical advisory panel, and you can see the names of the clinical advisory panel members at that time highlighted in pink. And this consortium had different goals, but one of the goals was to work on information that could be used for building a next version of the WHO classification. And in 2019, a meeting was organized in Utrecht at that time, during which an update was discussed, new entity and diagnostic principle recommendations of See Impact Utrecht meeting for future CNS tumor classification. Let me see, here you see the flyer for that meeting. And the white paper that came out of this meeting was published in Brain Pathology. But a lot of the information that was in this paper indeed has been used in the WHO CNS 5, the 5th edition of the classification. So compared to other areas in oncology, we were pretty well organized, and it took less stress of the participants to figure out what should we do to make the classification up to date. And now, See Impact Now, NOW stands for not officially WHO, so it's not under auspices of the WHO. But in this Utrecht meeting, there was representation from the IARC or WHO. So then, for that time, it was then officially WHO. Then the process was started for preparing for the next WHO classification, the 5th edition. And there is a standing members, part of the editorial board, and expert members. And the two colleagues highlighted in red are the clinical colleagues that were participating in this expert part of the editorial board. Unfortunately, we had to deal with COVID-19. So it was not possible to have real live meetings, and we had to discuss a lot by Zoom. This was not the official picture, but I figured out I'd better put a picture in there so you know that I was present. But after all, it was really not optimal, but I think the end product was okay. But it's much more difficult to discuss stuff when you are doing it via Zoom meetings. Well, the end product of these deliberations, these discussions, is the WHO classification, the Blue Book with 192 contributors, and it really is teamwork because no one can cover each and every detail of all the tumors that are described here. So it's a huge team effort. And sometimes discussions are difficult because you have to reach consensus, and people can have strong opinions or large egos or whatever. So it needs some political maneuvering as well as discussions based on contents. And each and everyone involved recognizes that there are a lot of strings attached to building a WHO classification. First and foremost, we think of what's the deal for the patients we are confronted with. But then it also has impact on how to organize clinical trials for experimental studies. So what kind of tumor are you actually working with according to the present day standard for establishment of population-based disease trends and for allocation of resources by the government. So it depends on the number of patients there are, how much money there is available for the different patients, or patients and for the healthcare in that area. And then you have the people that are more conservative. They don't want to disrupt patient management too much, are afraid that we spend too much money, etc. And you have colleagues that are really progressive in a way. They want to make rapid progress, provide the best possible diagnosis, use the most recent tools and the latest markers. And here you see the 5th edition, published, the digital version, the website version was published in 2021, and the Blue Book in 2022, but it's known as the 2021 CNS tumor classification. A nice overview of what changed in this WHO 5th edition classification is published in Neuro-Oncology, as you can see here. The digital version really is a big plus. It was not present for the previous versions, but this is very handy. You can have it, as you all know, I guess, but right on your iPad or other device, and click on the tumor and then find information on these tumors. And what's also important is that right after the activities for the CNS tumor classification started, there were also people starting working on the pediatric tumor classification. And I was invited together with Stefan Pfister and Tom Jake from London to take care of that part. And one of my main goals was not to have too much discrepancy between what was published in the CNS5 classification and the pediatric tumor classification, because before you know it, people use different classifications and then there's maybe confusion. And that was pretty successful because we copied and pasted most of the information from the CNS5 classification into the pediatric tumor classification, as long as it concerned tumors that occur especially, or at least with some frequency in kids. There's a paper published with a summary of the pediatric tumor classification. Part of it is on the CNS tumors, but this covers all pediatric tumors in cancer discovery. So this is nice background information on the pediatric tumors in more general. And that's the first part of my talk. Maybe I can stop and ask if there are questions or comments. You can also tell me it's very boring, and then I try to convince you that the second part... Sorry?
And I will stop forever.
Yeah, I'm not sure. No questions yet?
Thank you.
It's obviously an internationally based organization and classification system. How do you see the newer version using molecular techniques applying to the majority of patients who are treated in low middle income countries who maybe don't have access to that kind of techniques easily?
That's a huge challenge. And in the past, the WHO or the IARC had a kind of approach that each and everyone around the world should be able to use the classification, and otherwise you wouldn't make changes, because it's not a good idea to have something available for the haves and the have-nots are not able to use it. But the danger of not making progress is that the haves will start building their own classification, and things are not comparable worldwide anyway too. And one of the changes I've noticed is that in the past, pathologists had to do their job in a relatively inexpensive way. So they made some histological slides and immunohistochemistry, and that was it. And we had a very rapid diagnosis. And now molecular diagnostic kicks in. And before you know it, the price is 3, 4, 5 times as high as for the pure morphological analysis. But the question then is it worth it? And when you compare the costs for the right diagnosis to what happens to the patient in other areas, like the imaging that's continuously performed or the treatments that are given very expensive sometimes, I think it's worth spending money on the best diagnosis, because then you know what you're dealing with. And at the same time, a lot of the molecular diagnostic tools become less expensive. So hopefully, in different ways, the information we have now in the 5th edition of the classification will also be more usable in other areas. But I'll get back to that in the 3rd part of my talk.
Hi, I saw on one of your slides there's this idea of democracy and oligarchy in deciding. These things aren't always as clear-cut as we might think. And how do you, when you had disagreements about whether something should be a classification and how you present this data, how do you come to a consensus about how you do that? With regard to the contents, after discussing over and over again, most of the time there's at least some level of consensus that can be reached, and then you can have a kind of minority opinion also included in the text. So the WHO classification actually is the list of tumor types that are recognized, and then the rest of the blue book is explanation of the classification. And in the explanation you can put, let's say, minority opinions or something, if it's really necessary. But I first thought you were going to ask about how do you get equal representations from different areas in the world for endeavors like this. And that's also a kind of difficult debate, because officially, I'm pointing there, I'm not sure if Lyon is there, but let's say Lyon is there. Officially, the IARC and WHO are very keen on equal opportunities, distribution around the world. Different continents should be equally represented. And then, before you know it, they say, well, at least 5 colleagues from Africa should be involved in building the WHO classification as well. But a lot of countries don't have a pathologist who is very familiar with these tumors. And when they are, it's just based on histology. It's a completely different situation. So I see that there is tension between, on the one hand, this good goal, and on the other hand, how you make progress in a pragmatic way. And it's not solved, but the same is true for males versus females. Males were very dominant until 30 years ago, and now you see, like here, I guess, the females are dominant, at least number-wise. Yeah, right. I have a wife who is very keen on male-female, how do you say, equality. So I know what to say. Hey, are these the questions? If so, I'll proceed with the second part. And that is a kind of helicopter view on what the changes are that were made. So this is the cover of the Blue Book. And in the Blue Book, when you look at the classification itself, so these 2 pages with tumor types, you recognize category of tumors that are the overarching larger categories. Within that categories, you have different families of tumors. And within the families, you have the actual tumor types, and sometimes there are also subtypes within these types. And some tumor types were not fully established yet, but considered to be mature enough to be included as provisional tumor type. But there is a chance that in the next edition they will disappear again, and hopefully they were not that, we were not too progressive in that respect, so there is more evidence then that they can indeed be a regular tumor type in a new classification. Here you see the categories and families I just referred to. So the larger categories are gliomas, glioneuronal tumors, and neuronal tumors. And you could argue why not put them in different categories, but a lot of these tumors belong to a spectrum, so it's difficult to make up your mind, are they really glial or glioneuronal or glioneuronal rather than neuronal? So these are combined. And then you see the families of tumors, I'll get back to those. Another category is embryonal tumors, and then you have on the right-hand side the tumors that occur somewhat less frequently in kids. And today I'm going to focus mostly on the more frequent tumors, but a bird's eye view. And tomorrow I'll have the opportunity, I hope, to explain somewhat more about medulloblastomas and about high-grade gliomas. That's what I got from the program, at least. This is the actual classification, as I said. So the 2 pages of tumor types. And the rest of the book is basically explanation. What are the clinical, imaging, histopathological, molecular characteristic, what is known about prognosis, that kind of stuff, epidemiology. For instance, when we look at diffuse midline glioma, which is now called H3K27 altered rather than H3K27 mutant, I'll get back to that later on. It's a tumor type that belongs to the family pediatric type diffuse high-grade gliomas and to the category of gliomas, glioneuronal tumors, and neuronal tumors. General changes include the fact that tumors are now grouped according to different approaches. When it's possible, they are grouped according to genetic changes that allow for a complete diagnosis. But for some tumors, the genetic background is not completely clear. So there are tumors for which the diagnosis is really still based on histomorphology plus or minus immunohistochemistry. Grading used to be performed overall CNS tumors and using Roman numerals, but that's now Arabic numerals that are used, and grading is performed within a particular tumor type. Nomenclature was made as simple as possible. I'll give some examples of that. Here you see tumor types with revised nomenclature or revised placement, and this is a lot of information, but I try to highlight those changes that maybe are the most relevant for you. So H3K27 mutant is changed into H3K27 altered. Raleigh fusion positive ependymoma is now called SEFTA fusion positive because SEFTA is the more frequent partner in the fusion, and most often these SEFTA fusion positive ependymomas have a fusion with Raleigh as fusion partner. Embryonal tumor with multi-layered rosettes used to be defined or have the name as C19MC altered. And when this was not present, it was NOS, not otherwise specified, but now we know that sometimes DICER1 mutant cases exist, all or not in the context of a germline problem. Adamantinomatous craniopharyngioma is now a separate tumor type. It used to be called craniopharyngioma, and then you had the adamantinomatous or papillary subtype, now a separate type. But this is basically something that the endocrine pathologists were very aggressive about. Pituitary adenoma is not the WHO name anymore. It's now pituitary neuroendocrine tumor. And the reason being that not each and every pituitary adenoma behaves in a benign fashion. And you don't see it right away based on histology alone. I'm not sure if this is the best move because we also know that meningiomas not always are very indolent. But anyway, this is the way it was organized. Here you see diffuse midline glioma H3K27 altered. And a nice thing about the WHO CNS5 classification is that for each and every tumor type, there's now a table with essential and desirable diagnostic criteria. And this is something that people can use in daily practice to check, do I have indeed enough features to make that particular diagnosis. Here you see the essential criteria listed on the right side and desirable criteria here. But there are, as I just already referred to, different sorts of diffuse midline glioma H3K27 altered. And the good news is that for quite some cases you can already make a definitive diagnosis, maybe not the most precise diagnosis because you would like to know somewhat more about the molecular features, the characteristics of the molecular features, but you can already make the diagnosis based on morphology and immunohistochemistry, using immunohistochemistry for the H3K27 mutant protein, M mutant protein, and the flip side of that coin is staining for H3K27ME3. So when there's K27M mutant protein staining in tumor cell nuclei, you don't expect the K27ME3 staining anymore. And here's another example of a quite frequent pediatric tumor in the posterior fossa, where the diagnosis, according to the WHO, can be made based on immunohistochemistry, loss of the H3K27 or K28ME3 staining. It depends on where you start counting, whether it is K27 or K28. Same is true for G34 versus G35. But that's a detail I will not discuss further right now. Or you perform methylation profiling, and then in the vast majority of the cases you get right away the suggestion that it is a PFA-type methylome profile. And in addition to that, and also discriminating it from most PFB ependymomas, these tumors have a flat CNV profile, copy number variation profile, and the PFBs have more coarse copy number alterations, losses and gains of chromosome parts. And then there are newly recognized tumor types. A lot going on, as I already suggested in an earlier part of the talk. Again, you don't have to remember this all, and you can later on have a look at the slide what the new tumor types are that are included in the WHO classification. The ones in gray are the provisional tumor types, but most of these new tumor types are in the category of glioneuronal tumors or embryonal tumors. And here you see it in somewhat more detail. So what's new is that there is now a family of tumors, pediatric type diffuse low-grade gliomas and pediatric type diffuse high-grade gliomas. Ependymal tumors, the diagnosis of those tumors is much more refined in the latest WHO classification, and the category of other CNS embryonal tumors is much more specific. And here you see what changed for the diffuse astrocytic and oligodendroglial tumors, comparing the WHO 2016 with the 2021 classification. In 2016, there was already the diffuse midline glioma H3K27M mutant. It's still here, but now called H3K27 altered. I'm repeating myself, I now realize. But here you see that then there is a family of pediatric type diffuse low-grade gliomas, including the MIP-L1 altered tumors, angiocentric gliomas. They are pretty close to each other, so maybe in the next edition of the WHO classification, this is becoming one and the same tumor type with different morphologies. You have the MAPK pathway altered diffuse low-grade gliomas, which is more a heterogeneous group, but the common denominator being MAPK pathway alteration. This is a very rare tumor. And you have the diffuse high-grade gliomas, including the DMGs, diffuse midline gliomas, and also the diffuse hemispheric gliomas, which have the G34 or G35. Don't I have enough time?
No, I want to ask you a question.
Oh, okay.
Am I allowed?
Yeah, but you're in the corner of my eye.
Now, you mentioned that you also considered if it's important, if it's clinically relevant. And now looking at this list, I wonder, how did you decide this was important?
Right. Well, relevant can have different meanings, but we'll get back in the last part of my talk about how to deal with all these new tumor types, etc. But the fact of the matter is that you don't have series of tumors that were investigated in the past So for a lot of these new entities or new tumor types, we're not completely sure what the best treatment is. But on the other hand, biologically, they are often really different. And then it would be kind of stupid not to recognize them as different. The next question then is, when a diagnosis is made of such a new tumor type, how to deal with it. But that's something for, as far as I'm concerned, a multidisciplinary meeting and see where the tumor fits best according to the older standards.
Sorry, I'm no neuro-oncologist, but I don't think you do the classification according to targeted therapies we have now, but or do you do in that way? Because
No.
targeted therapies come after your classification, I guess.
Right. I'm very well prepared because this is also in the third part of my talk. Yeah, right. Hey, and about splitting versus lumping, before you know it, pathologists are splitters. They are keen on details on the square micrometer. But I know that Uri suggested that we should make separate types for the germline or the germline cancer syndrome related tumors, right, Uri? Because they are different.
Hi guys, I'm Uri, and I'm the client of his. I'm the neuro-oncologist. So we suggest to work on the drivers. Doesn't matter if it's germline or not, because mismatch repair tumors, deficient tumors should be treated differently than the rest, and the same for V600E tumors. So we suggest to think together in the future how to use the drivers mutations and not necessarily methylation or morphology, because that drives what the customers, which we are all the customers, will treat the patients accordingly.
Right.
That's what we are saying.
Okay. Yes, yeah, okay, right. We'll get back to that later on when we talk about predisposition syndromes, etc. Okay, and here you see the new types that were included, but I've already covered those, I guess. In epidemoma group, you now have the PFA, PFBs, rare tumors, spinal cord, MIC, and amplified, which is really important because the spinal epidemomas were in the past considered as indolent or relatively indolent. And this is a very, very aggressive tumor. So it's good to know for the patient that this is not a good thing to have. Most tumors are not good things to have, but this is a very bad thing to have. And the embryonal tumors, as I said, in the group of other CNS embryonal tumors, there are now particular embryonal tumors that are listed as separate tumor types with particular molecular alterations. And what's interesting is that here is a group of CNS embryonal tumor NEC-NOS. NEC means not elsewhere classified. So when you can do the molecular analysis that's necessary and still cannot put it in a better defined category, you can add not elsewhere classified to your diagnosis, CNS embryonal tumor not elsewhere classified. And when you're not able to do the molecular workup of the case that is necessary, then you can add NOS, CNS embryonal tumor not otherwise specified, but that might be because you didn't have the chance to have a closer look at it. There's a separate chapter in the CNS5 book on genetic tumor syndromes, but that will be discussed tomorrow in more detail. And for the sake of time, I would say go to the Blue Book and see the details there and or read the articles I just mentioned. The last part is about challenges. Questions from the audience? So far so good, or do you have a postprandial dip?
It's not freely available, right?
Sorry?
It's not
No. But no, and in a way that's a pity. You mean the digital version? Yeah, well, I would like it to be freely available, but it has to be paid in one way or another. And the good news is that you don't have to buy the more expensive book anymore. And when you buy access to this website, you have all the tumor information that's available, including on the genetic tumor syndrome. So it's not freely available, but it's much better available than it used to be. So we're able to make much more precise and or objective pathological diagnosis, but what are the consequences for therapeutic management? And you need to have the molecular tools available in order to be able to make those diagnoses. Those two topics will be elements in the last part of my talk. Not very recent anymore, but quite recent paper we were involved in from Utrecht as well was this one. Recurrent views in plaque L1 define a distinct subset of pediatric type supratentorial neuroepithelial tumors. And in the process of writing this article, they tried to sell it as another supratentorial ependymoma, because quite some of these tumors have perivascular pseudorosettes. But then quite some other tumors with this molecular alteration don't have these pseudorosettes. So is it right then to call it ependymal tumor? What's the minimum criterion for ependymal tumor? So it ended up as being called supratentorial neuroepithelial tumor. And I have some problem with that, neuroepithelial tumor. Here you see some histology. Also because it was suggested to be included in upcoming WHO classifications. But the question is then, where do you put it? Neuroepithelial tumor, what's that? It can still be an embryonal tumor, basically, because neuroepithelium is something I associate with a neural tube. But is it then something that should be treated as glial, high-grade glial, embryonal? Not clear right away. And one of my colleagues from the US quite recently wrote a paper or an opinion piece on neuroepithelial tumor and suggested that we are exchanging the trash can for an industrial-sized dumpster. And what he means, I guess you are pretty, or most of you are much younger than I am, but in the more distant past, there was a term PNET, primitive neuroectodermal tumor. And that was a term that was quite often abused because when it looked very aggressive and a relatively small cell, already soon the diagnosis would be PNET, primitive neuroectodermal tumor. And later on, it appeared that this really is a very mixed bag of tumors. But now that we start calling tumors neuroepithelial tumors, the same might happen again. Plus that for some colleagues, NET is neuroendocrine tumor rather than neuroepithelial tumor. This is a quote I like. Those who do not value history are doomed to repeat it. So always good to look back at what happened. Emerging tumor types, I highlighted the neuroepithelial ones here, but there are other ones that are put in the glioma category right away or in sarcoma category, and sometimes in have a name that suggests a mixture between sarcomatous and glial differentiation. Because of all these new developments, after 2021, C-IMPACT now has restarted its activities. And this clinical advisory panel has slightly changed. So now Uri is part of the team, and he will guide us in a way that it becomes much more valuable for you as clinicians, is what I'm hoping for. One of the topics for the next round would be CNS tumors occurring in patients with a germline tumor syndrome. But maybe we have to rephrase this a little bit, we'll see. Nowadays, the pathologist has to have, ideally, a lot of different tools compared to 30 years ago, because you would like to do DNA and or RNA analysis and methylome profiling. A couple of days ago, this paper was made available online. It's a online version before print. But this paper nicely explains what kind of molecular tools there are and what the pros and cons are of the different tools. And you see here the H&E, good old H&E stained slide. Then you can do immunohistochemistry. And for a lot of people in the world, this is what they can do. And before you know it, immunohistochemistry is not state of the art. So there are flaws in the way they do immunohistochemistry. So that's a problem. But when you are lucky enough to be in the area where the haves are, maybe you can even use methylation profiling, but DNA next generation sequencing or RNA next generation sequencing also solves a lot of diagnostic problems. And the focused assay, so the panel analysis for DNA alterations, also is still very valuable. But I have to say that when you do the more genome-wide or exome-wide analysis, you get a lot of information in one test, and it's sometimes less expensive than performing different tests for the different alterations that you're looking for. Here you see what the costs are and how long it takes before you have the result. And if you can multiplex the test, so for instance, the single gene analysis, you have to do case by case. See impact now, not otherwise specified versus not elsewhere classified. I've already explained this to you. So this is a way in which people around the world can still use the 5th edition of the WHO classification, but everyone realizes that it's challenging to make up your mind, is it fitting in the glial tumor this or that type? So I can imagine that sometimes you end up with high-grade glioma not otherwise specified. But then that's it, and you know that the colleagues have been trying to put it in a category but don't have the means to do it in a more precise way. And on the other hand, you have the not elsewhere classified situation, a designated situation in which necessary diagnostic testing was performed, but the results do not allow for a specific WHO diagnosis, and that's then the most recent version of the CNS tumor classification you should look in. This gets back to what you were referring to. The WHO classification, so far at least, is based on especially diagnostic and prognostic markers, and not on predictive markers. But maybe the predictive markers are much more important for the patient. For instance, when there is an immune therapeutic approach that really solves the problem for the patient, you don't care too much about what the exact type of tumor was, as long as you have markers that predict that this immune therapeutic approach will work. So when there is a panacea for each and every tumor, you don't need the classification anymore that we have been building so far. Unfortunately, that's not reality yet. But at the same time, I do agree that predictive markers, so predicting the success for a particular therapy, are very important. But so far in the centers I'm working in, we use it as a next layer of information. So we make a diagnosis according to the WHO classification, and in addition to that, tell what kind of predictive markers there are. But the classification itself is not based on the predictive markers, because these predictive markers, not infrequently, are quite promiscuous. So for instance, BRAF V600E mutation can occur in a lot of different tumors with quite a diverse outcome for the patient. And I'm also not sure, but Uri can tell more about that, if the targeted treatment for this alteration is as successful in the different tumor types with this particular alteration. Meanwhile, there also is a recent publication, but that's about glial, glioneuronal, and neuronal tumors, published in Neuro-Oncology from the EANO group. It's an EANO guideline, and we looked what is known about predictive markers in these different tumors, what is the evidence that it works, how frequently does it occur. And the best situation is when you have an ASCAT, what's it called, score 1, that's red, and here you see BRAF V600E mutation. It's very frequent in pleomorphic centroastrocytoma. The larger the ball, the more frequent. Blue is the second best, but you see that there are a lot of tumors where there's not yet enough evidence-based information to suggest that targeted treatment will work for these tumors. This is on both adult type and pediatric type gliomas and glioneuronal tumors, so also maybe interesting for you. We need to take care that we don't create a schism in the way that the front runners are losing contact with the rest of the group. So David Lewis once said, when you're 10 feet ahead of the parade, you're leading the parade, and when you're 10 blocks ahead of the parade, you're no part of the parade anymore. Since you're, most of you are somewhat younger than I am, do you know who this is? No. Oh, yeah, that's the second name. Yeah, yes, I found it funny because this is Louis Armstrong. So it's not David Lewis, but Louis Armstrong. Here it's shown. Louis wishes you a cool Yule, whatever. What can we do to bridge the gap? There are different ways to deal with it. Development of less expensive molecular tools, or maybe surrogate tools using immunohistochemistry. In Utrecht, we are working on a nanopore sequencing-based approach, and there are several benefits of using that tool because it's less expensive, much more rapid, and it even allows for intraoperative assessment of the methylation group when enough representative tumor material is available. AI-guided analysis of histology, maybe I'm dreaming, but could sooner or later also play a role here. Then you see that some colleagues in particular areas of the world are collaborating on making recommendations on how to get as close as possible to the WHO classification. Adopter Consortium, adapting diagnostic approaches for practical taxonomy in resource-limited regions. And there are research or reach-out programs, for instance, Heidelberg, St. Jude's, Princess Maxima Center are actively pursuing bringing opportunities to other centers. Part of the problem is that in the other centers, maybe you can have the best diagnosis, but then you don't have the treatment available for these patients. So it's not solved by having a better diagnosis right away, obviously. We as pathologists were in the past kind of nerds in the basement and socially awkward, as you can imagine. And we were looking at slides, performing thin slicing, so deriving information from very limited information. But most of the time we were pretty well on target. But more and more we are working in what you can call augmented reality. And this is the bright future of the pathologist, the pathojet, where you have everything digitally available and can work from wherever such a pathojet is installed. This is what I would like to share with you. Thank you for your attention, and are the questions.
Thank you, Peter, for this futuristic, interesting presentation. I don't know if there's we have time for a few questions, if all your questions have been answered.
I would like to know, is this something you can work with, or are you thinking, well, let him take another stroll, please? Huh. Is it something that's useful for you, or what should I have done differently?
You need to help him out here. He's getting insecure, please.
No, well, no, you know, I could have talked about the exact histological features of diffuse midline glioma or what kind of immunohistochemistry you should use, but that's not something you're waiting for, right? Because you're not going to do it yourself. You're also not going to check what the pathologist exactly did, but it's good to have some clue. And then, once again, take a look in the blue book and you see exactly what the features are that the pathologist uses for making the diagnosis. So anyway.
Can I say something? So really, it's amazing to hear Peter talk. For us, it's just a pleasure, and I think you guys need to be more active because that's why you're here. But just before that, do you see this type of molecular diagnostics and pressure and tension like Peter and I talk to each other in sarcomas? I don't think so, isn't it? There's nothing, guys, nothing changed. I just talked to Michael. Whatever I learned in 1995 or so, the same therapy today, isn't it? Wilms tumor, the same. So the tension is the pleasure. You guys, the neuropathologists, the molecular, and sometimes us are in tensions in meeting. Is that important, as you beautifully said in the second part of the talk? What do I do with a new fusion? Is that, but that's amazing, isn't it? So we'll discuss maybe later in this, because we have case presentation, what we think is important and what's not. But the anxiety that we have in neuro-oncology is a pleasure that we never had. It was very simple to treat brain tumors, isn't it, when Catherine and I were young, because we had chemo A, chemo B, and then you go home to die. Now, they are surviving. Oh, should we give less toxic therapy based on molecular? In rounds, the neuropathologists tell us what to do. Actually, you look at the things, and there are two papers that you mentioned. You guys need to read them in neuro-oncology. The new one, which is really preprint, isn't it?
Yeah.
And the one that you said in gliomas, which are the things we need to look at? This is the way they tell us what to do. So it's not about learning about IDH1 mutation, what to do. It's for you guys to say, how we are thinking in brain tumors, how we use, because you go home and you need to work with your neuropathologist, and if they don't care, they need to talk to Peter. And we are looking in a different era, and I don't see that, unfortunately, just because of maybe luck, in solid tumors and some of the hematopathologists, which is, again, the classification is still the same. We are not using the molecular alterations to treat the patients differently. So I would like to say thank you, but also excite you guys to ask questions.
Thank you.
Maybe the helpful question would be, how many centers, just raise your hands, have dedicated pathologists, like neuropathologists, lymphopathologists, solid tumor pathologists? Okay, majority.
Yes, but you're all from Europe, I guess?
Yeah.
Right. I mean, we are already a pretty privileged continent, right? But still within Europe, there's quite some difference in opportunity.
I think thanks for thanks for talking. It was really, it's nice to hear it all set out. I found it very useful personally. I'm sure other people did. I think the big problem we have in the UK at the moment is kind of access to neuropathology. So it's not fully set up yet in terms of where different centres send the tissue, and the turnaround is a real struggle. It's kind of 4 to 6 weeks at least before we get a diagnosis, and it can be longer. And obviously, you need to start treatment before that often, especially if it's a highly malignant tumour. Is that something that's common in Europe? Was it talked about as a problem in terms of access to all these molecular stuff, or is it just, from a pathology viewpoint, are you just like, well, we'll give you a diagnosis and you'll get it when it's ready, or how does it work? How does it work?
Well, based on what you
There's a lot of friction. The clinicians are like on the ground.
Yeah,
I mean, I
yeah.
don't know what it's like in
Well,
Canada,
I think
but
the Netherlands are in a special position because we now have one national pediatric oncology center, and it's a small country, and basically each and every kid that is diagnosed with cancer has his diagnosis performed, or the pathology workup performed, or at least supervised in this Princess Maxima Center. And we run, for instance, methylome profiling twice a week. So this means that we have, within a week, the result of methylome profiling ready. We routinely, but I think it's somewhat exaggerated, because it's not necessary for the diagnosis, but then the idea is that you build a database that you can use for very good research. But we also perform RNA sequencing and whole exome sequencing on most CNS tumors, and that may take 1.5 weeks, but still well within the time that you can use the information for therapeutic management, deciding on therapeutic management. I see the problem in the UK, or England, maybe I should say. I know Tom Jacques very well. He is in London.
yeah, so London are fine, and some centres are sending it to London now,
Right, but then it
it's
takes
like,
too
but
long.
it's not the same everywhere, basically.
No.
I don't know what Bob thinks about it in Leeds, but anyway, it's just it's a struggle.
Stefan?
Maybe I can comment briefly also from the trial perspective in Europe. I'm Stefan. We conducted the PNET-5 trial and just finished recruitment last year. It was open in 14 European countries, and the novelty of that trial was that molecular characterization was required upfront before inclusion of the patient. It was in low risk and standard risk medulloblastoma patients, so it was an OM-WINT arm and a standard risk arm. And when we started the trial in before 2014, we had a lot of discussions whether this would be feasible on a European level. And in the beginning, we lost a few patients due to logistical problems and timescales, as Peter mentioned. But later on, it was perfectly easy and feasible. And I think apart from the benefit that the biobanking and the trial will provide us a lot of information, high-quality information in future, the major benefit is that in these 14 countries, it's now an automatical thing to freeze down in top quality any posterior fossa tumor, and why not others, by the way, and then characterize them within 2 to 3 weeks before the start of adjuvant treatment. So I think it's really feasible even on a multi-center level.
Another question. Thank you, Stefan. By the way, Stefan, I'm still a bit angry about you because you asked me to give this presentation in 20 minutes. No, I'm kidding.
You talked about nanopore and the ability potentially to have intraoperative MDTs. Sort of, is it pie in the sky thinking to think that every centre eventually will be able to afford one of these and everyone will be having intraoperative MDTs? Or how would we select the cases who get an intraoperative MDT, do you think?
I'm not sure. MDT is molecular diagnostic what?
So getting the results intraoperatively via a nanopore
right.
making the decisions.
No, the point is that I can provide a link to all of you with the final version of the paper that's on medRxiv, and this work has been submitted to Nature, and they responded quite well, but now we had to resubmit and show that we actually could perform it in real-life intraoperative procedures. And then it takes 60 to 90 minutes, but most of the time neurosurgeons say they don't need it, but in pediatric neuro-oncology, when they start operating on a posterior fossa tumor, it is very important to know, is it an ependymal tumor, or a medulloblastoma, or a pilocytic astrocytoma, or another embryonal tumor. And the trick with the nanopore sequencing approach is that you use sparse information and match that with the database that was built based on Illumina methylome profiling. And when, for instance, you have a picture of a parrot of tens of millions of data points, and you only have 10,000 data points, you still may be able to recognize this right away as a parrot and not as a cat. And that's what happened, basically. Do you need it all the time? No, I don't think so. But then you can proceed analyzing the specimen, and you have the final result within a couple of hours rather than within 1.5 or 2 weeks. And the armamentarium you need is not the Illumina armamentarium, but a kind of stapler size stuff from, Oxford Nanopore Technology. I don't get money from them, so I'm free to say this, to share this. So that reduces cost and speeds up the process. It needs to be validated much more extensively, but that's maybe one way to circumvent the problem of things being too expensive and or too slow. That's what I'm hoping for.
Thank you.